Welcome to this chemistry review. So this review is for you. If you are at home and you have some time, it might be a good idea to go through the review just to make sure you understand all the concepts. And as always, if you have any questions after the review, just come to class. Hopefully you'll watch the review maybe before the night before, but even if you watch it on Tuesday night, you can always come in Wednesday morning and ask for clarification. So again, this will be a chemistry review. Now, we've been spending a lot of time on the periodic table of elements. And when you look at the periodic table of elements, you should notice, and you should be able to do lots of things. For example, if I look here, you see these numbers right here? Do you remember what these numbers mean? Well, first of all, these vertical columns are called what? If you say groups or families, you're absolutely correct. And these all the way through 18 are the families of the periodic table of elements. Does anybody remember what these numbers mean? These are what we call periods. And the way I distinguish and remember the difference between periods and families is that because these are horizontal rows, for example here, and I remember horizontal rows, sentences are in horizontal rows, and at the end of a sentence you have a period. That's how I remember the difference between periods and groups. Now, you should be able to also tell a couple different things, and you should have gotten this through periodic table basics. One, if I was to number this 1, 2, we're going to forget these elements right here in the middle. We're going to just forget them about now. And if I renumber this 2, 3, 4, 5, did anybody catch that mistake? There should be a 3, there should be a 4, there should be a 5, 6, 7, and 8. And this is handy to know. Everything in this first period has 1 electron in its outer shell. Everything in this family has 2 valence electrons, or electrons in outer shells, and so on and so forth. So there's 3, there's 4 in the shell here, 5 in the outer shell, 6, 7, and this one has 8 electrons in the outer shell, or at the very least they're full, because we obviously know that helium does not have 8 valence, it doesn't have 8 electrons, period. But we do know that it has a full outer shell. And for the K shell, remember, if you have 2 electrons, it's full. The L needs 8, and for the first 18 elements, the M can actually hold 8, and it'll be full. That's why they consider argon to be full. Now, when we look at this periodic table, we should know that, well, we should be able to distinguish between the gases. And here, they actually have them as being red. Oop, we got to get chlorine in there. And then there's hydrogen over here. And then we should know that there's 2 liquids right here. And right here we got bromine and mercury. And the rest are going to be solids. We should know that the difference between metals and nonmetals. The metals are going to be over here in this area. We've got some transition elements here in between. Sometimes these are called metalloids. And then we have the nonmetals. So a nonmetal doesn't necessarily mean it's a gas, it just means it's not metal. It could be a solid. For example, carbon is a nonmetal, but it's a solid. So looking at the periodic table, can you do all that? Can you figure out where the families, where the periods, how many valence electrons they are? That's definitely something you're going to want to be able to do on the test. Now, when we look a little bit more closely at one of these elements, this is from the table you saw. This is boron. We should know that this is the symbol. Okay? We should know that this right here is going to be the name of the element. Okay? Now, some people have a hard time distinguishing between these two. This is going to be the atomic number. Okay? So this is your atomic number. And this is going to be your mass. Now, typically, but not always, it's usually like a 10.81. And the reason it's 10.81 is because it's an average of the isotopes. Now, there's a couple things that you need to know also about this. First of all, what two things go together to make up the mass? It's going to be your protons plus your neutrons. And that's where most of the weight in an element is. It's in the protons and it's in the neutrons. And we need to know that this atomic number is equal to several things. It's also equal to the number of protons, and it's also equal to the number of electrons. So if you know those things, you should be able to fill out this chart right here. For example, here's helium. Now helium has 2 electrons, but what 3 things are equal, do you remember? And I always use my favorite vegetable, the pea, because I remember that protons equals the electrons, which equals the atomic number. So if I know I have 2 electrons, well, the atomic number and the protons equal. And I can do it for carbon too. They're going to equal. And I can do it for chlorine as well. They're going to equal. Now, how do we get to neutrons? Well, remember, protons plus neutrons equals what? The mass. So we got the mass number right here. So 2 plus what equals 4? 2. Now here it's a little bit different. Here's 6 protons and there's 6 neutrons. So here I've got those 2, but I don't know the mass number. Well, 6 plus 6 is 12. And sometimes it'll get a little bit harder. Here we have 17 plus, I don't know how many neutrons there are, equals 35. Well, if I just subtract 17 from both sides, this cancels out. I know n equals what? Well, it's going to be 18. And I know 7 plus 5 is 15, and I carry the 1, and that'll make 35. So you have to be able to do this on a test. So again, if you're not clear about this, come see me before we get too much further. On a test, you should be able to draw a Bohr model. For example, here is a Bohr model. It's got atomic number 4. Its atomic mass is 5. Include the protons, the electrons. So it's really important that you look at this information. One, you're drawing a Bohr model. Now the atomic number is going to be 4 and has a mass of 9. So you're going to need to know this. Let's look what else there is. There's protons. You have to put the electrons in there. You have to have the neutrons in your model. You have to label the charges of the protons and the electrons. And you have to place the electrons in the correct shell. So what I first want to do is I want to figure out how many protons there are. And if the atomic number is 4, you should understand that there's going to be 4 protons. And how many neutrons are there? Well, if the mass is 9, 9 minus 5 equals 4. Okay, so then I'm going to draw a circle around there. That's my nucleus. Now, I could also use that for my first electron shell if I wanted to, but I'm going to draw a different one. And I'm going to grab a different color pen. Let's go blue. So now this is my K shell, right? Now I don't have to label my shell, but I do need to know that's my K shell. And I also need to know that the K shell can hold 2 electrons before it's full. Okay, so I have to look at this right here. Its atomic number is 4, so I know it's going to have 4 electrons. So I'm going to just put an E here to symbolize my electrons. That way there's no mistaking it. So I'm going to have 2 in this shell right here. Now I'm going to need another shell because I need to put a total of 4. So if I draw my next one, sorry, that's not quite straight, is it? So I've already used 2 electrons, so I'm going to just put 2 more electrons out on here. Now, am I done? Can anybody answer that? Question should be no, because what didn't I do yet? If I looked at this and I highlighted, I did not label the charges of the protons and the electrons. So if I go back to a pen, let's pick a different color here. Let's go green. Okay, I have to know my protons. I can simply just go, oh, protons is plus, electrons is negative. What are the neutrons? Neutrons are neutral. They don't have a charge. So if I ask you on a test, you know, the nucleus of an atom typically has what type of charge? You would say a positive, because it is. Or if I say, well, the electron cloud typically has what type of charge? What would you say? You should say it's a negative charge. Okay? So let's move on. You know, this is what you might see on a test right here. You're going to have some matching. And some people struggle with matching, so I just want to, you know, review this with you a little bit. Now, first of all, you always do the ones you know first. For example, protons. Ooh, protons, positively charged. Ooh, I know that's going to be protons right away. And then once I fill it in, I'm going to take it off here. Okay, neutrons, negatively anything. Electron, oh, negatively charged particles. I know that's going to be the electron. I know it for a fact. So I know those. Those are the two that I'm most comfortable with. Anything that has mass and takes up space. We talked about this in class. That's matter. Matter is anything that has mass and takes up space. So I'm going to cross this off. So do you see how I'm eliminating answers? So if I go to another one, form of matter containing only one type of element. Well, if I watch the notes, I'm going to know that's an element. So I'm going to cross that off. So now I'm left with three, an atom, a neutron, and a molecule. So particles in an atom's nucleus that have no or do not have an electrical charge, ooh, I know that right away, is my neutrons. So now I have these two. A building block of matter, I know is going to be my atom. And a building block of a compound is going to be my molecule. So when you're working on these, I would suggest you cross stuff off, do the ones you know first, and maybe even go to the rest of the test and then come back later. So, went the wrong way. So make sure you can do things like this, where you can find the protons, you can find the neutrons, find the electrons. Can you find these? Okay. Now, did you figure out which one are the protons, which one's the atomic, or not the atomic, but which one is the atomic number and which one is the mass? Well, you should have figured out it should be the smaller ones. So I know it's going to have 17 protons, it's going to have 17 electrons, and then again, we worked with this one earlier, 35 minus 17. Okay, remember how to do this? You have to borrow. 15 minus 7 is 8. 2 minus 1 is what? 18? Yep. So see if you can do this one. Did you notice anything different about it? Okay. One, you should have noticed that it is chlorine, so that's something that's the same. But did you notice how the mass is slightly different right here? It's 37. So I know my protons, I know my electrons, but if I take 37 minus 17, I'm going to have 20. And you might be saying, oh, what's going on? Is there a mistake here? No, no, no. There's no mistake. This is actually called an isotope. This is one of the words that we have on our word ceiling. You're going to need to know this for a test. An isotope is the same element. It's got the same number of protons. It has to have the same number of protons. It has to have the same atomic number. But, looky here. It's got different numbers. It's got different mass numbers, so it's going to have different numbers of neutrons. So an isotope is the same element, just different number of neutrons. And that's how they average, and that's why some of these masses are like 1.0079, because they average all the isotopes. Now, this has just been a quick review. These are a lot of the things you're going to need to know for the test. So go over the vocab sheet, make sure you can do a Bohr model, make sure, if we back up a little bit, make sure you know how to read this. Make sure you can fill in a chart similar to this. It's going to be very similar to this on a test. It's just going to have different elements in it. You should be able to do that. And make sure you know all these different things about the periodic table. So hopefully, sorry about that. So hopefully you'll watch this sooner rather than later. And if you have any questions, come in before the test and I will help you out. Thanks.